Over-provisioning is the silent budget killer. Industry data shows average cloud resource utilization at 23% CPU, 31% memory, and 45% storage. That means 60 to 77% of what you're paying for goes unused. For a mid-size company running 50 Kubernetes clusters, over-provisioning wastes an average of $847,000 annually.
The root cause isn't negligence, it's fear.
Engineers over-provision because under-provisioning causes outages, and capacity planning manually is time-consuming, error-prone, and always based on outdated data. AI capacity planning agents solve this by making right-sizing safe, continuous, and automatic. AI capacity planning agents ingest 5 data streams continuously. Historical metrics: 90 days minimum of CPU, memory, network, storage, and request volume data for every service. Business calendar: known events, marketing campaigns, product launches, and seasonal patterns that affect traffic.
Deployment schedule: upcoming releases that might change resource requirements.
Traffic patterns: daily, weekly, and monthly cycles plus trend direction. Growth trends: user acquisition rates, data volume growth, and transaction volume trends. The agent generates capacity forecasts with confidence intervals, not single-point estimates but ranges that account for uncertainty. Forecasts update daily and adjust in real time when patterns shift. The difference between predictive and reactive scaling is the difference between zero downtime and customer-facing latency. Reactive scaling: traffic spike hits, latency increases, alert fires, engineer or autoscaler responds, new capacity provisioned, recovery. Total impact window: 4 to 8 minutes of degraded performance. Predictive scaling: agent detects pattern indicating traffic increase in 45 minutes, prescales capacity, traffic spike arrives, zero latency impact. The agent learned that every Tuesday at 2 p.m., batch processing job spikes CPU demand. It prescales at 1:45 p.m. Every month end, reporting queries increased database load 300%. It prescales storage and compute on the 28th. Predictive scaling eliminates the performance gap that reactive scaling always has. Right-sizing without risk requires a systematic safety framework. The agent analyzes 90 days of usage data and identifies the 95th percentile peak, not average, not maximum, but the level exceeded only 5% of the time. It sets new resource limits at P95 plus 20% headroom. Changes apply to staging first with 48-hour monitoring. Production changes include automatic rollback triggers. If P99 latency increases more than 10% or error rate increases more than 0.5% after a right-sizing change, the agent reverts immediately. This framework means the agent can aggressively right-size development in staging environments where 70% of waste lives while being conservative on production. No human needs to approve a dev environment downsize. Production changes above 25% require approval. Demand forecasting connects capacity planning to business planning. The agent projects resource requirements at 3, 6, and 12-month horizons based on growth trends. Current API service handles 10,000 requests per second at 60% CPU. User growth is 12% monthly. In 6 months, you'll need 1.8 times current capacity. The agent recommends: add 2 replicas in month 3, upgrade instance type in month 5. Total additional cost $4,200 per month versus $23,000 if you over-provision now just in case. Finance teams love this because capacity planning connects to budget forecasting with data instead of guesses. Engineering teams love it because they stop getting surprised by capacity constraints during growth spurts. Capacity planning isn't just about cost, it's multidimensional. Optimization. Performance dimension: maintain P99 latency below your SLO target. Cost dimension: stay within budget allocation per team and service. Resilience dimension: maintain minimum redundancy for fault tolerance. The AI agent finds the optimal balance point across all 3 dimensions. Sometimes the cheapest option violates resilience requirements. The agent selects the cheapest option that maintains N+1 redundancy. Sometimes the performance optimal option exceeds budget. The agent finds the configuration that meets SLO at lowest cost. This multidimensional approach prevents the common failure mode of optimizing for cost alone and creating fragile systems, or optimizing for performance alone and wasting budget. An e-commerce platform with 52 Kubernetes clusters and $2.1 million monthly cloud spend deployed AI capacity planning. Initial analysis revealed 38% over-provisioning across the fleet, $798,000 per month in waste. After 90 days of AI-driven optimization, 18% overall cost reduction, $378,000 monthly savings. 0 performance-related incidents attributed to right-sizing. 3 capacity-related outages prevented by predictive scaling during flash sales. Finance team approved expanded AI agent scope based on ROI. The platform team's capacity planning meetings went from weekly 2-hour sessions to monthly 30-minute reviews of agent recommendations. The ultimate evolution is capacity planning as a self-service capability in your IDP. A developer requests resources through the internal developer platform. I need a database for my new service, expected 5,000 queries.